This is a video demonstration of DiMaC, an effective tool for cleaning disguised missing data, presented by Ming Hua from Simon Fraser University. First of all, what's disguised missing data? Basically, it is a data that's actually missing but appears as valid values. For example, when we fill out online surveys or registration forms, we sometimes do not provide real information. Like this guy from Washington State is going to fill out his address, but for different reasons, like he's private about his address, or he's just lazy and does not want to find Washington at the bottom of the drop-down list. He decided that he just chose Alabama instead of Washington, simply because Alabama is the first item and is easy to pick. In this case, his real state information is missing, but appears as Alabama. So Alabama is a disguise for this missing entry. If this happens to many people, then the quality of the collected data is heavily impaired. To solve this problem, I'm introducing to you DiMaC, an effective tool that can find the most suspicious disguises in each attribute of any datasets. Before going to the demonstration, let me first show you the idea of our solution. If every user gives the real information, then we can get a distribution of users and their state information. But unfortunately, some people did not provide their state information, so those are the missing data entries. It could happen to any person in any state. Therefore, those missing entries are a good sample of the whole dataset. What's even worse? Those people with missing information decided to use Alabama as disguises, because without providing the state information, they cannot proceed, and Alabama is the easiest one to choose. So they're in the same group as Alabama residents. In other words, the Alabama group contains a good sample of the whole dataset. If we think in the opposite way, to find out the state that's frequently used as a disguise, we simply check if this group contains a good sample of the whole dataset. This is the whole idea behind DiMaC. Now let me show you how to use DiMaC. First, we just need to put the dataset into the same directory as DiMaC. Press the Load Data button to load the dataset into the system. Now we can see our dataset. Right-click on the dataset that we want to clean. We can browse the data. On the left are the different attributes. We can further look into each attribute by right-click on its name. This example dataset is a medical dataset containing the clinical attributes of Pima Indian women with or without diabetes. Let's see if this dataset contains any disguised missing data. We can test each attribute one by one. For example, right-click on the blood pressure and choose Show Disguise. A list of suspicious disguises is shown on the right. Sort them by the score. We find the most suspicious value is 0, which makes perfect sense because normal person is very unlikely to have a blood pressure of 0. We can also check the frequency distribution of different values in this attribute. Clearly, 70 has the highest frequency because 70 is a very common blood pressure value. Compared to 70, 0 is not as frequent, but our system can still detect this disguise. As another example, let's find the most suspicious disguises in the age attribute. 21 is returned with the highest score. Why? According to the background knowledge of this dataset, it contains information of women with age at least 21. So 21 is a system default value. The conjecture here is, during the data collection, if the age information of any woman is missing, then 21 is used as a disguise. We can report the most suspicious disguise of each attribute of the whole dataset by right-clicking on the dataset name and choose Show Disguise. The second dataset contains the adverse events reported to FDA. Again, we report the most suspicious disguise for each attribute. For example, on the attribute event date, January 1st, 2003 is reported. The conjecture is, during the data collection, if the event date is unknown, then the first date of the year is used as a disguise. Those are the results already computed by the system. If we want to recompute all the results, just click Find Disguise. Choose the dataset and set the frequency threshold. If the frequency threshold is high, then the system only checks the very frequent values to see if there are disguises. Then press Find Disguise. Here we go. Okay, that's a little idea about DiMaC. If you're interested, please contact us at mhua@cs.sfu.ca. Thanks for your time.